differentiation. Differentiation calculus is a branch of calculus that investigates the rate at which quantities change in mathematics. The derivative of function as well as related concepts like differentiation and its applications are the main topic of differentiation calculus. The rate of change of function near a given input value is described by its derivative. Differentiation is the procedure for determining a derivative. The derivative of a function at a location if the best linear approximation to the function at the point for real value function with a single real variable. Types technique of differentiation is power, product rule, quotation rule, and the chain rule. The application that we will use is related.
Today I want to explain about the use of differentiation and how we can implement it on real life situation. Generally, there are many uses of differentiation that we can use, but for today I will only explain 3 examples that I considered simple and most reasonable among them. Firstly, we use differentiation to calculate the maximum and minimum profit of one's organization. For example, this is the graph of the function fx is equal to x cubed minus 3x squared plus 6. We can easily find the maximum and minimum point of this graph using the derivative function. Step 1. We need to assume that the slope on the turning curve is a horizontal tangent line. Step 2. We need to find the derivative of the function fx. Step 3. We need to equal it by 0 as the slope of horizontal tangent line is originally 0. And finally, by using basic algebra, we have found the point of both of these turning curves. Next, we can use differentiation to determine the speed or distance covered, such as miles per hour. For example, this is the graph for speed function. If we use derivative function on this graph, we can get a new graph, which is the graph of the velocity function. And if we use higher derivative on the speed function, we can get a new graph, which is the graph of the acceleration function. Lastly, we could use differentiation to find the range of magnitudes of the earthquake in the study of seismology. Usually, an earthquake magnitude is found by using the derivative of time on moment function.
For this video, I want to show you an example on how can we use differentiation on real life situation. First, let's assume that there is an engineer that wanted to build an automated ice cream machine. The average size of the ice cream cone is 16 cm with 4 cm diameter. If the rate of flowing ice cream is 8 cm per second, how fast is the height of the cone will change at an instant if the cone is filled with 4 cm height of soft chocolate.
So we know that we need to find the h over dt. The blank is dv. We just know about the dv over dt because it's in here, the rate. So we write here dv over dt equal to 8, and we need to find dh over dv. So firstly we need to do the ratio. The ratio of the cone is 4 over 16. So 1 over 4h. Okay. Formula for cone is 1 over 3 pi radius square height. Okay, we do the integration. 1 over 3 pi 1 over 4 h power of 2 and h. So 1 over 3 pi h square over 16 h. Power of 3, 48. So we differentiate the formula. dv over dh equal to 3h square over 48 pi dh over dv equal 1 over 3 h square over 48 pi dh over dv. So 1 over 3 h square 48 pi multiplied by 8. So the answer 8 3h 248 pi 8 48 3h2 pi. And for the final question, include the h is 4 when I equal to 4 dh over dt equal to 8 multiply 48 over 3 we h is 4 power of 2 pi. So my answer is 8 multiplied by 48 pi. So 8 over pi.
Finally, we can conclude that
Ice cream.
it will increase at the rate of 8 per pi centimeter per second when the height of the water is at 4 centimeter.
For this video, I want to show you another example for differentiation and how can we use it in real life situations. But first, let us look at this scenario. Hello Miss Aina, I have finished the decoration for the birthday party. Wow, it looks great. I know I could trust you, Alia. I am so glad to hear that. And oh, do you have anything else to change? Let me see. Spotted. I want the balloon to be a little bit larger. Can you do that, Alia? I think so too. I will fix it and it will be ready by 9 PM tonight. That is great. Alright, see you tonight. Alright, so now let us help Alia with this situation. So first of all of the balloons are sphere in shape and identical. Alia inflated the balloons by using the helium gas tanks at the rate of 6 cm³ per second, and the balloon radius is 20 cm. Miss Aina wants her to increase the size of the balloon, therefore Alia decided to increase the balloon radius by 5 cm. Alia need to find the new rate of change of volume of the balloons to adjust the helium gas tanks. Therefore, what is the rate of change of volume when the new rate of change of the surface area for the balloon is 4 cm³ per second? So for the calculation, we need to find the rate of change in volume of the sphere balloon. So first we look at what the question give us. So the question give us the rate of change of surface area, which is 4 cm² per second. Therefore, we can conclude that this is dA over dt. And then we have the new radius, which is 25 cm because the old radius is 20 and the new and Alia said that she want to add 5 cm more to the radius of the balloon. Therefore, we will have 25 cm as the new radius of the sphere balloon. Next, the question told us to find the rate of change in volume. Therefore, we know that the rate of change in volume is dV over dt. The next step, we know that we need to find dV over dt and we have dA over dt. So we need to use the chain rule to build an equation to find dV over dt. So we have dV over dt and dA over dt. So we need to multiply it with dV over dA to eliminate the dA and get dV dt over here. But how do we find dV over dA? So as we can look here, we can build dV over dA by multiplying dV over dr and dr over dA. Therefore, we can break it into three parts: dA over dt, which is A, dV over dr, which is B, and dr over dA, which is C.
So first, let us take a look at A. Okay, so A we know is dA over dt, and dA over dt is given in the question, which is 4. And we need to look if the rate that has been given is positive or negative. So in this case, it is the rate of surface area increasing because we inflate the balloon. Therefore, it is positive over here. We look at B, which is dV over dr. So to find dV over dr, we need to use the formula for the volume of sphere, which is 4 over 3 pi r cubed. So we differentiate 4 over 3 pi r cubed, and we get 4 pi r squared. Therefore, we can conclude that our B is 4 pi r squared. Next, we need to find dA over dr. So to find dA over dr, we use the formula for the surface area of sphere, which is 4 pi r squared. Therefore, we differentiate 4 pi r squared and we get 8 pi r. However, in the equation that we built using the chain rule, we use dr over dA. Therefore, we need to exchange the place between the numerator and the denominator of this of the value dA over dr that we get. Therefore, we exchange it to get dr over dA. It will become 1 over 8 pi r. Therefore, we can conclude that C is equals to 1 over 8 pi r. Right. So now we got the value of A, B, and C. We substitute it back to the equation. So value for A is 4, for B is 4 pi r squared, and for C is 1 over 8 pi r. Therefore, we can see here that we can cross out, we can simplify this. So we'll get r, and here we will get 1 over 2. Therefore, when we multiply it, we will get r over 2. Therefore, 4 times with r over 2. But remember, in the question, we need to find the rate of change of volume when the radius is 25. Therefore, we substitute 25 into this equation and we solve it. We will get 50. So the rate of change of volume that we get will be 50 cm cubed per second.